Hello everybody, welcome to this lesson whereby we are going to deal with trigonometric identities using the Moivre's theorem. Now, from our previous lessons, we've seen that if you have a complex number z raised to power n, this is identical to r raised to power n cos n theta plus j sin n theta. Okay, using the Moivre's theorem. This is true using the Moivre's theorem. Okay, so if we have another complex number z raised to power negative n, raised to power negative n, this means that r minus n into bracket cos minus n theta plus j sin minus n theta. Okay, we all know this to be true. Okay, we have done this in our previous lessons and we understand this. Now I want to take a case whereby our r is equal to 1. Okay, our modulus r is equal to 1. If our r is equal to 1, this will have z will be identical to cos n theta plus j sin n theta. Okay, our r is 1. Okay, and our z raised to minus n will be cos of minus n theta plus j sin minus n theta. Okay, now if you were to get zn plus z minus n, if you were to add z raised to power n plus z raised to power negative n, just a little note which you should know from trigonometry is that, little side note which you should know is that, cos of minus theta is identical to cos theta. Okay, cos of minus theta is identical to cos theta, and cos sine of minus theta is identical to minus sine theta. Okay, from trigonometry you should know that cos of minus theta is equal to cos theta, and sine of minus theta is identical to minus sine theta. So what does that mean? That means that if you are to add z raised to power n plus z raised to minus n, z raised to power n plus z raised to power minus n, z raised to power n is cos n theta plus j sine n theta. Okay, so z raised to power minus n, instead of writing it like this, since we know that cos of a negative angle of minus n theta is identical to cos n theta. Okay, and sine of minus n theta is identical to minus sine n theta. So these and these are the same thing. Okay, just written in a different way from our trigonometry. This identity should be well known to you. It is true that cos minus theta is identical to cos theta, and sine of minus theta is identical to minus sine theta. Okay, good. Now we are adding them. We are adding these two. So cos n theta plus cos n theta is 2 cos n theta. Okay, plus j sin n theta plus minus j sin n theta. This is 0. That means that z raised to power n plus z minus n is identical to 2 cos n theta. Okay, and this, people, is our first identity which you should learn. You should learn this identity. We'll be using it a lot. This is our first derived identity. Okay, that zn plus z minus n theta, zn plus z minus n is identical to 2 cos n theta. Okay, good. Now we move on. If we have zn minus z minus n, this will be identical to cos n theta plus j sin n theta, and we are minus, we are subtracting it from cos n theta minus j sin n theta. Okay, we are subtracting this time round, and if we subtract that, cos n theta minus cos n theta is 0, plus j sin n theta minus minus, which is positive, j sin n theta, that will give you 2j sin n theta, which means that z raised to power n minus z minus n is identical to 2j sin n theta. Okay, so these are the identities which you need to learn and know, for you'll be using them a lot, and it will save you an awful lot of time in future when working out this type of questions. So I really advise that you learn these identities. Z raised to power n plus z raised to minus n is identical to 2 cos n theta, and z raised to power n minus z raised to power minus n is identical to 2j sine n theta. Okay, so let that marinate, and I will see you in our next lesson. Thanks for watching. This is Understanding Math.